the amount of kinetics that you would need to form all of this limestone would boil away all the Earth's oceans. You wouldn't be able to form that limestone because you wouldn't have any medium to do it in, because all the oceans would be boiled away. The crust would be melted. I mean, there is not a process. The amount of heat and pressure that it would take to speed up all these chemical reactions would physically destroy the planet.
Okay, let's go back to the argument that you presented. Here is Boudreaux, a Louisiana alligator. Old Boudreaux here goes back to an earlier critique that you had of my point of view, and that is when these crocodile-like creatures are found in the rock record, where are the transitions to it? And see, my problem, since I was first introduced to this in my undergraduate days at Tennessee, is I'm aware that you can find creatures like Archaeopteryx that have teeth and are bird-like. I love the line that Dwayne Gish used to use in both the 70s and the 80s. He would say, well, some birds have teeth, some don't. Some of you have teeth, and some of you don't. And
name one bird that has teeth.
Okay, I think it begins with the letter H. I'll have to look that up.
If I could jump in, are there any living birds today that have teeth, David?
No.
To answer Grayson's question?
I don't know the answer to that, but I do. Well, maybe I do. I'll have to look that up as we go through the rest of the night.
The debate tonight is about how can a flood explain the order of the fossil record? Because, the last time we had this conversation, I brought up the plankton question, where we find plankton segregated into layers based on the species. And a flood is physically incapable of doing this. There is no way that water can sort different kinds of plankton according to species into different layers. I would be happy to hear a model that you're putting forward to explain how this is even physically possible in reality. Because as we see it today, water sorting, hydrological sorting, is incapable of reproducing what we observe. So that's the central challenge. That's the central key issue that I would like to hear you touch on tonight.
So my argument is this, Grayson, that it's fully, it's a good model that a tremendous flood covering a worldwide continent would go across, and as those waters moved, they did move, contrary to what you're arguing, through ecological niches. And so the bottommost layer, you would expect to find trilobites in and other marine creatures. And then as you go up, I'll use this University of Tennessee orange here as my second layer. The second layer would be Cambrian, Ordovician, Silurian, not always found, not even found in the Grand Canyon in a complete sequence. But as you go up through this group of layers, as the floodwaters move them across the earth, they would form blanket sediments, just like Ager argued about the chalk. By the way, I challenge you to provide a reference to modern chalk formation. I'm aware of modern limestone formation in the Caribbean Ocean, but not chalk. But the point is the persistence of this. Now, your argument that, okay, McQueen, in your flood model, how can you explain that different species are actually the driving force of the order of the fossils? The challenge that you brought up about plankton, I'm going to defer to Thomas in the second half of our debate, he and I have taken you, Grayson, into the biology lab, and we've kind of dissected you up, and he gets certain pieces of you and I get certain pieces of you. So I'll leave the plankton argument to my colleague Thomas there. An argument I'd like to hear you address is during this first part of the flood, the first 6 months, as the water was rising, creatures like man and dinosaurs would have been able to move to higher elevations.
Okay, well, that was pretty wild. Didn't I guess you're just not going to address the plankton question. You're going to leave that to TRock. Fine, I guess. But again, I would like to see some explanation of the fossil record. So far, what I was hearing was that there was some kind of advantage to intelligence, mobility, and habitat to where the animals could go to higher ground if they were smarter and more mobile. But again, that completely fails to explain the fossil record as we see it, because we don't see that kind of effect in the fossil record. Numerous types of animals that would have the same ability to do what you're talking about and to move out of harm's way and to get to higher ground are not found buried in the same layers. They are still segregated by species. Like, for example, like types of dinosaurs, or like types of synapsids in the Permian versus mammals from the Cenozoic. All of those large animals would have about the same of mobility to move away from the floodwaters. And yet, all the mammals, like the big herbivorous mammals, are in the Cenozoic, and the big dinosaurs are in the Mesozoic, and the big Permian synapsids are in the Permian. So they are segregated by these layers that a flood is still not explaining. I mean, again, the point of bringing up the plankton was that they have the same body plan, the same body density, same intelligence level, same mobility, and live in the same habitat. So again, that's the second point with this whole ecological zonation idea, is that we find animals that occupied the same type of habitat segregated into different layers based on, again, their species. So how can a flood do that if it's the same environment? I mean, you don't want to talk about plankton. Fine. Plankton all live at the top layer. So that they need to, or not all plankton, but the phytoplankton that do photosynthesis are all at the top. So that's the same habitat. But we can also, we can look at the dinosaurs that shared the same forest habitats, that, were with the creatures below and above them in the fossil record. Or we can look at, in areas in the fossil record where you have one specific location and you have multiple habitats all stacked up in the fossil record. Like at the bottom, you might have a swamp, then you might have an inland sea on top of that, and then you might have a desert on top of that. And how does that work in a global flood? I mean, the global flood cannot explain what we see with our own eyes when we look at the fossil record. You have to be where chalk is forming today, at the bottom of the oceans. That's how chalk forms. The coccolithophores die and sink down and start building up these chalk layers. I am shocked that you even bring up chalk, because how does chalk form in a global flood? The waters have to be very calm and like in the right temperature range for like chalk and limestone to even form at all in the first place. Like the cliffs of Dover pretty much debunk the flood in the whole first place. I mean, that's like, 300 feet of chalk? How can that possibly be formed in a global flood? I mean, I know you love pointing out the Bahamas and the limestone forming there today. Guess what? It's still not forming fast enough for you. And it's a different kind of limestone that's forming in the Bahamas. There's multiple kinds of limestone, and it's the one in the Bahamas is oolitic limestone, which can form faster than more like hard limestones. But again, different kind of limestone than we're observing in Dover in the White Cliff. So that doesn't help you either. And even if it was the same kind, it's still not fast enough to possibly be explained. But all the limestone we see in the world today forming in a flood, it's just physically, it does not work. Honestly, I'm not hearing anything justifying how a flood can physically form these layers that we observe segregated by species. Like if you give me a Jurassic layer, I can tell you all the types of fossils you'll find below it and all the types of fossils you'll find above it. So you have to explain how that could possibly be even possible if the flood happened. How can we know what fossil species are going to be above the Jurassic and what fossil species are going to be below the Jurassic? How is that possible?
This is where Grayson is wrong in some of his vocabulary. When you look at the synapses and you find them in Jurassic, Triassic, Permian, different rock units, my challenge, Grayson, is you don't seem to know where these words come from. The word Triassic, for example, is a rock unit in Europe in which these synapsid creatures are found. And so that becomes an index fossil for the that part of the Mesozoic, and then that gets carried worldwide. Where's the transition between something before and the synapsids that you commented about?
Well, we do have transitions in the Carboniferous era. So they're the earliest synapsids and the transitions to synapsids are tetrapods within the Carboniferous era. I mean, if you wanted me to give you a specific genus and species, I can Google that for you. I don't have it off the top of my head, but again, I mean, just to be clear, I'm not here tonight defending evolution. That is not my point in being here. Even if I just concede that entire point to you, I don't think it changes the nature of this debate at all, because I thought that this was supposed to be how the flood explains the fossil record. So whether or not evolution is true has no bearing on that topic, because you still have the fossil record there observed that needs an explanation. So it seems like all of your points tonight have been trying to attack the consensus explanation for the fossil record rather than build a positive case for how the flood could explain the fossil record.
Well, my friend, I'm actually shocked at your comment. So what I've already told you has changed your mind? You don't view yourself as a evolutionist?
No, it's just not the topic of the debate tonight. The debate topic, in my mind, was not evolution. I'm not here to defend evolution's explanation of the fossil record. I'm here to pose the fossil record challenge to you and the creationist camp to explain.
Okay, Donnie, you want to go on to the next question there? I guess Grayson can pose that to me. I'm sorry,
Sure.
We're not at the question part. I want him to elaborate on some point he's made, like the fact that limestones can't be formed in the Caribbean in the modern context or something like that.
Okay, let me jump in. David, appreciate the first question, the first topic that you kind of went back and forth there in a little bit. Grayson, if you'd like to ask a more on-topic question, feel free to do so, whether it's limestone or the ordering of the fossils or something to do with plankton. However you'd like to proceed and move forward in the discussion, go ahead.
Okay, well, I'll just say that the what I mentioned about the earliest like synapsid transition in the Carboniferous period is called Archaeothyris, I think. I don't know the pronunciation, but I'll just post that in the chat here so that you can read the name and do some research on it yourself, because I think that you'll find that is a pretty good example of a transitional Archaeothyris in the Carboniferous, the earliest known synapsid with a lot of features that are quite different from the later synapsids. So that's a good example of a transitional there. I mean, we could go all night and I could just continue to list transitionals to you. Or I think that I would like to focus on the chalk and limestone question, because I've seen you bring it up before, and it really is such a devastating gotcha for the young Earth side of things. So I would like to hear the explanation for how the flood could form these thick limestone layers like at the White Cliffs of Dover, because again, what my point was in the Bahamas, because I see you bring that up often for limestone currently being formed today. But the rate that limestone is being formed today cannot be used to explain the limestone that is formed like today if the flood model was accurate. Like there's not enough time. Like the rate at which it's being formed per year is like what, like centimeters maybe. So it would need to be forming what, 300 feet in 1 year in your model. Like how can that possibly happen?
Okay, let's turn to the issue of limestone formation and give you an explanation from the standpoint of flood geology of how these can form quicker than what you think. I've been drinking tonight some alkaline water that's pH 9. That's supposed to help me. The argument that I have used that I think you have no answer to, my friend, is based around the geochemistry of calcium carbonate. So if we look at CaCO3 and break that down, one thing we have to be concerned about is the partial pressure of carbon dioxide in the water. But in addition, and by the way, for some of you that are following along, when Grayson uses the word carboniferous, another way to think about that is Mississippi and Pennsylvania, that part of the upper part of the Paleozoic record. But if we look at make sure that I'm putting this where people can see it. If we look at the chemistry of the modern Caribbean Ocean in the Bahamas, we have a number of factors that play into the formation of what I'm calling micrites, M-I-C-R-I-T-E. Now, you commented that's what actually is in Andros Island is oolitic. I'll need to have to look that up, but that's actually a moot point in this geochemical argument. The formation of this micrite is due to variations in pH, temperature, the electrical conductivity around the atoms of calcium and calcium carbonate. That's called EH. So you got pH, temperature, EH. You have the partial pressure of CO2 gas dissolved in the flood ocean. And so I don't think you should trivialize what's happening in the Caribbean, because these micrites there, I'm not spelling this right, these micrite limestones, micritic muds, you and Donnie and I could go on vacation down there, walk out on Andros Island, and actually be walking in micrite mud that has been formed in the not too distant past. The idea of flood geology, the way it ties into this, is that large or thick units, I should say, of limestone, and imagine these claws again being hundreds of meters worth of limestones, they could directly precipitate out of an ocean very well suited to the conditions of a great flood. What do you think about that, my friend?
Yeah, I don't think that any of the processes that you've listed so far are physically capable of going fast enough to happen within 1 year, like 12 months to form the limestone that we see today.
Okay. My critique to that revolves around, and I'm sure in your undergraduate training, you had to suffer through chemistry just like I did. And the issue that you're bringing up about time is the chemical issue called kinetics. I think I'm misspelling it. Kinetics, K-I-N maybe.
Yeah.
Kinetics is the part of organic chemistry. I'm sorry. Well, it applies to organic chemistry too, but it's the part of
Physical chemistry.
Physical chemistry that controls the rate of a chemical reaction.
Mm-hmm.
And I think your criticism of the young Earth view, my view about the origin of limestone, is wrong, because since you're looking at present processes to try to explain past events, how can you know the kinetics of the past from the standpoint of chemistry?
Because if the kinetics are, again, kinetics on a chemical level is the same thing as temperature on a macro level. So if the amount of kinetics that you would need to form all of this limestone would boil away all the Earth's oceans. You wouldn't be able to form that limestone because you wouldn't have any medium to do it in, because all the oceans would be boiled away. The crust would be melted. I mean, there is not a process. The amount of heat and pressure that it would take to speed up all these chemical reactions would physically destroy the planet.
Okay, let's go back to the argument that you presented. Here is Boudreaux, a Louisiana alligator, what's left of him here. And let's talk about the place in the rock record that we find alligators such as this.
Mm-hmm.
One thing that I don't think you properly proved is, okay, an alligator is a reptile. Where is the evidence of transitional organisms leading up in the rock record to old Boudreaux here?
The Protosuchians.
Well, is that adequate to explain the origin of reptiles like this? I'm going to ask you in our next break if you would type in the exact name of that transitional form, because again, I think in this book, the fossil record that I'm referring to is 10 years old, and you should be aware of these critiques that primarily the zoologist Frank Sherwin has put in here, and I will look that up and respond to it once you type the name in. So it's archeo.
So that was the earliest synapsid. Looks
that's
kind of like a lizard superficially. I just said Protosuchus just because it's an early crocodiliform. So like what you're generally asking for is like the crocodiliforms are a group in total that are like they're not true crocodilians or alligators. They are like kind of in a similar group of crocodilomorphs, but those were in the time of the dinosaurs. So those are what we find. We don't find modern alligators and crocodiles down in those Mesozoic layers. We find crocodilomorphs. So that was what I was pointing to.
Okay, well, old Boudreaux here goes back to an earlier critique that you had of my point of view, and that is when these crocodile-like creatures are found in the rock record, where are the transitions to it? And see, my problem, since I was first introduced to this in my undergraduate days at Tennessee, is I'm aware that you can find creatures like Archaeopteryx that have teeth and are bird-like. I love the line that Dwayne Gish used to use in both the 70s and the 80s. He would say, well, some birds have teeth, some don't. Some of you have teeth, and some of you don't. And
name one bird that has a tooth, that has teeth.
okay, I think it's begins with the letter H. I'll have to look that up.
If I could jump in, are there any living birds today that have teeth, David?
No.
To answer Grayson's question.
Do you know? I don't know the answer to that, but I do. Well, maybe I do. I'll have to look that up as we go through the rest of the night.
So really
but
quickly,
again, my point that you've challenged me on is if this flood model is true, then how in the world can you, McQueen, explain the presence of crocodiles a bit higher in the rock record than, let's say, no, I want to use another example. Crocodiles higher in the rock record than plesiopods or gastropods that you find. Well, I think the flood provides a good explanation that things like plesiopods and gastropods, clams and snails would have been buried first, and then the crocodiles could survive a bit longer and go up through the record. Okay.
So really
go
quick,
ahead and pick our next topic.
Yeah, I just wanted to respond to some of what you just said. There are no birds alive today that have teeth. There are some birds you can find that have ridges in their beak, but ridges are not teeth. Even like you can superficially, maybe a 5-year-old might get confused and call those teeth. But real teeth are, ask a dentist what a tooth is. A ridge in a beak is not a tooth, okay? The actual fossil record has Mesozoic birds that have real teeth, not just ridges in their beaks, but real teeth. And in fact, most of them in the Mesozoic have teeth. So again, how can a flood possibly sort birds by whether or not they have teeth? How is that possible? I mean,
and so let me be clear on your argument. So an example of a fossil creature that is bird-like and has teeth would be Archaeopteryx then, right? Is that
sure? I mean, we can come up like Ichthyornis is another example. I mean, there's a ton of different bird specimens. Like some of them look kind of superficially like modern seagulls, but with teeth. So how can a flood sort? Like again, all of the birds that have teeth are in the Mesozoic layers, and all the birds that don't have teeth are in the Cenozoic. How does a flood sort a bird based on whether it has teeth or not?
Okay, let me respond to that by what I perceive as a misunderstanding on your part about the vocabulary of Paleozoic, Mesozoic, and Cenozoic. And we've talked a lot about Mesozoic units, so I might as well use that as my counter argument to what you're saying, clarification on what you're saying. The evolutionary timetable going from Cambrian 600 million years ago to our Cenozoic rocks, I would argue is completely artificial. And actually, the vocabulary of it was first introduced by creationists. And we'll use the Mesozoic as an example. So here's the Mesozoic. And then in the Mesozoic, as you're going supposedly always up in the rock record, you have Carry Out Some Dinner, Miss Penny Pearl, to Johnny Clock, Triassic, Jurassic, Cretaceous, and then Quaternary up here. And so let me challenge you on this Triassic group of rocks in Europe. The tri part of it has to do with 3 basic colors that are found in that group of rocks, in which are found, as you correctly point out, fossils of dinosaurs and other creatures. Now, I want to return to paleobotany again. Also in these rock units here, you find appearing abruptly and fully formed leaves of things like oak trees and pine needles, things like that. But back to my argument here, these rocks in Europe, the Triassic, were first studied in the 1700s and 1800s by creation or flood geologist types. And so they assigned this name. Well, what happened in the years after that? So the European geologists that were being trained in, let's say, 1850, they were trained on what this Triassic would look like. And so once they graduated, and many of them came to America as professors, when they got over in the eastern part of the United States, they saw, again, these are based on colors, they found some Triassic, what they would call Triassic, they found some red beds. Now, these red beds in the eastern United States are found in a tectonically unique area in the Appalachian Mountains. But nonetheless, they are red beds. They contain some dinosaur footprints even. But the reason that they're called Triassic is not because of some evolutionary magic. They are called that because the students identified them in Europe and brought the vocabulary to America, South America, Australia. You see my argument here?
Yeah, I mean, it seems like you're just describing stratigraphic correlation, specifically lithostratigraphy, where you're talking about matching the different kinds of rock layers.
Yes, very much so. Yeah, very much so. Yeah.
Yeah, so stratigraphic correlation is not just done through lithostratigraphy. There's also biostratigraphy and chronostratigraphy using radiometric dating. So all three of those methods can be used in conjunction and agree with each other. So I don't understand, like stratigraphic correlation is kind of the foundational bedrock of geology, pun intended.
Yeah, and your point's quite right. But what you're missing in this argument, I think, is that the vocabulary for a rock unit like a Cambrian rock unit that contains trilobites in a red sandstone, I don't think you appreciate where that vocabulary comes from. And let me present it. You've clearly watched some of my previous debates, and so this may be news to some of the audience. I'm hoping it's news to you. And that revolves around, if I draw a big inverted triangle here and let this be north, and we'll put London, England right here. And this is the part of England that is called Wales. We'll put that there. There was a professor named the Reverend Adam Sedgwick, again, someone who equally believed what the Bible said in the first bit of Genesis about the flood. And he was also a geology professor. And so each year, as he would teach in the greater London area, he would go to the board and he would say, we're going on a field trip to Wales. And when we get there, we're going to find some sandstone that's got a green mineral in it called glauconite. It's going to contain trilobites. And we will see it in stratigraphic layers, catastrophically produced in the idea of Sedgwick in this part of Wales. So I can just see, because I've been a college professor, I can just see this poor man year after year writing this all up on the board. Well, it turns out in this part of Wales, there's an ancient Celtic tribe called the Cambrian. And so Sedgwick came up with the idea, well, instead of writing all this up, why don't we just call this the Cambrian, which became the first unit of the Paleozoic? Why don't we just call this Cambrian and be done with it? Well, Sedgwick was teaching during the grand exodus of geologists from England to Australia and Africa and other parts of Europe, and especially to America. So, Grayson, follow me on this. These young geologists, they immigrate to America. They begin to move down the Appalachian Mountains to where I grew up in Tennessee, and they began to see red sandstones and shales with this green mineral glauconite in it and trilobites. And so they sat back on their horses and they said, well, what? Oh, I know what I'll call that. I will call that Cambrian. And so the use of this word came over from England. But what's my point on this debate? Not only are these rocks in the Southern Appalachians able to be correlated with their fossil content through Nova Scotia and over into England and Europe, but what's more to the point, the actual nature of these rocks and how they are formed in the Southern Appalachian Mountains fit a flood model better than an evolutionary viewpoint. Why? Because the trilobites in the units of the Salk sequence appear abruptly and fully formed. Again, you're not pointing me to particular genera of trilobites that are older than the Cambrian.
Well, yeah, I don't really need to, but the point is, like, I mean, that was an interesting, etymological history lesson there. But again, it doesn't matter what we call these layers. Like the fact remains that things are sorted in the layers by species. Even if we just look at trilobites, the trilobites in the earliest Cambrian layers are different than the trilobites in the Ordovician or the Silurian. They are segregated by species of trilobites. So again, a flood cannot sort trilobites according to their species. So the trilobites themselves are sorted into these layers, and we don't need to appeal to stratigraphic correlation at all. We don't need to appeal to global layers at all. We can look at one single site that has these different layers, and we can look at the fossils in the same site, and a flood still cannot explain that. So we don't have to go on a global scale at all. We can deal with just one site, the layers there, and the fossils segregated by species. Water, hydrologic sorting cannot do that.
Donnie, step in here and give me a sense of time. How much time do we have left?
We're doing well on time, and we just hit the 29-minute mark, and we got 40 minutes. So if I could reiterate Grayson's last question, Grayson, confirm if I've reiterated it accurately, and we'll get David to respond. So you're basically asking in response to David's argument, how does a flood sort specific creatures according to their specific species, such as trilobites in this case? Okay. Yeah. Okay. David, if we could get a response to that, go ahead.
Thank you for that clarification. And it is from my viewpoint, Grayson, I realize there are different looking trilobites in different Cambrian units worldwide. My basic argument is they are different looking in the same sense that my 4 children actually look different than my wife and I. We've been blessed with 10 grandchildren. They all look different, but that does not make them a different species. They're still Homo sapiens. And so some of the paleontological arguments about the nature and the speciation of different organisms fascinate me. In my research, my friend George Bond passed over an interesting thing to me. There are some salt units that are considered by the evolutionary community to be 250 million years old. They have resurrected bacteria from those salt layers, and the DNA is similar to modern bacteria. Shouldn't mutations over 250 million years have caused an alteration in their genome? Well, you can wait, let me finish my point here about the order in the fossil record, and then maybe you could take that up. There is an overall order in the fossil record, and I fully acknowledge that. But I will argue that there's only one place in the Morocco Mountains in northwest Africa where you can start in the Cambrian and really walk all the way up through Cambrian Ordovician, through the Mesozoic, and into the Cenozoic. So there is one place where that order follows. But ordinarily what we see is what we see in the Grand Canyon. If you look at this as the Grand Canyon, I'll put a tree up here to indicate that this is a cross section. We find rocks without fossils, which I would call Creation Week rocks or Precambrian rocks down here. And then you do find this Cambrian unit in the Grand Canyon that's called the Tapete Sandstone that does have fossils in it. And so as you go up, the evolutionary prediction would be that you would find Cambrian and then Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and this is all the Paleozoic. Carry out some dinner, Miss Penny Pearl, the Permian, up on top. Well, when you actually go to the Grand Canyon, as I have hiked it 5 times in 4 years, you do see the Cambrian. Almost no fossil record about Ordovician. Silurian is completely missing. There are some fossil fish, so there is some what would be called Devonian. And then you get to the top of the canyon where you find the Coconino Sandstone. And sure enough, you do indeed find the footprints of reptiles or amphibians that have been moving up subaqueous dunes, but the actual fossils themselves of whatever made those tracks are washed away. So the nature of the stratigraphic record is not as you suggest. In other words, if you go to one of the best places on earth to look at things, you do indeed find Cambrian, you do indeed find some Ordovician, Devonian, and then this upper Mesozoic trackways here. But my challenge to you is, how do we know that the Tapete Sandstone is Cambrian? Well, we know it because it contains an index fossil of a trilobite. How do we know that this is Devonian, named for the Devonshire area of England, where there are abundant fish fossils? Again, we know it because of an index fossil, and then the trackways are the same. Do you find the index fossil argument bad somehow, Grayson?
I don't even know what you mean by that question. I mean, you're just describing biostratigraphy, and like I already said, there are more methods available to us than just biostratigraphy. We can use radiometric dating, chronostratigraphy to say, and by the way, you're just bringing up unconformities, like those are caused by erosion. So yeah, I mean, it's not like a big mystery or explanation. It's also, Morocco is not the only site in the world where you can observe the complete geological record from the Cambrian on up. There's places in the United States where you can do that. I think it's maybe North Dakota or Wyoming or Montana, in that general area. There's a site in the US for that. There's at least 30 sites worldwide where you can see the full geological record. There you go, laid out for you. So Yeah, you made one point about like, I think I might have missed it. Were you saying something about 250 million year old DNA? That makes no sense. There's no DNA that's 250 million years. I don't know what you're referring to with that.
Well, I can send you the link that George Bond shared with me, but in that link, they apparently sequenced, I guess would be the right word, the DNA that was found in this 250 million year old salt layer. And when they compared that genome to modern bacteria, it was almost identical.
Right.
And
So it just sounds like you had some bacteria in your sample, right? I mean, it's not a big mystery.
oh, you're saying it was contamination?
Yeah, that happens all the time. I mean, this is pretty well known by paleontologists. You can take like you can find little DNA samples in like dinosaur bones, and when you test it, guess what? It's just bacteria that was on the dinosaur bones. It wasn't dinosaur DNA. So yeah, I mean,
So you're a critic of this whole soft tissue, Dr. Schweitzer?
no, not at all. I am
Yeah.
a big fan of Mary Schweitzer. Mary Schweitzer did not find DNA. She found collagen fragments, which, like, proteins can last for that long. The proteins are not DNA. DNA cannot last that long. But the types of fossilized soft tissues that Mary Schweitzer found are all totally in line with what is physically possible for 70 million year old bone. And by the way, Mary Schweitzer started as a creationist. Then when she got an education, she learned about evolution, and she's now thoroughly in the scientific consensus camp, even though she challenged the consensus successfully with her work, and she was proven correct. I do not disagree with Mary Schweitzer's work at all, and it does not dispute an old Earth. In fact, it argues just the opposite. Mary Schweitzer's results are not they do not fit within a young Earth model. A young Earth cannot explain what Mary Schweitzer saw, because the state of the organic material that Mary Schweitzer was finding, the type of molecules and the state they were in, cannot be explained in 6,000 years. It requires millions of years to explain what she saw in her microscope.
Grayson, you've touched on something that has been a criticism given to me many times. My undergraduate's from Tennessee. I've got a master's degree from Michigan. I've got a science education degree from a school here in Louisiana. So you're probably right. I have been educated beyond my intelligence years ago. So I may have some gaps there, but I'm still concerned that whether we're talking about the microorganisms in chalk or the kinds of calcium carbonates that are found in micrite, I'm concerned that you're not seeing the link to the fact that you really do not need a Earth that's millions of years old to provide a model for these. Now, let me be quick to add that when we would go out from the Institute for Creation Research to debate at University of California, Irvine, the different places we went, Dr. Morris would turn to us and say, now keep in mind that you work for the Institute for Creation Research, not the Institute for Creation Answers. And so his argument on that, again, going back to the Bible as a historical document, is when you turn to the third day of creation and you begin to read stuff like, and God said, let the earth bring forth grass and herb yielding seed and fruit trees yielding fruit after its kind, whose seed is in itself, that solves a lot of the traditional challenges. For example, which came first, the chicken or the egg? Well, from a creationist standpoint, on the basis of Genesis there, the apple had the seed already in it. So we don't have to evolve from ferns up to some sort of apple tree, and then go from that through roses and on up to a conifer. I think you're not providing enough in the paleobotany side of things of transitional forms.
Right. Well, I'm not here to do that. That's not what I set out to do in this debate. I set out to pose the challenge to you and to respond to your answer to the challenge, which so far has been to avoid it. I mean, I've brought up numerous examples of how what we see is irreconcilable with the young Earth creation flood model. And, you know, I agree with you that nothing in the Bible debunks the flood. What debunks the flood is reality and evidence that we see in reality. So, like, the fossil record, I mean, I haven't heard any responses to the points that I've brought up about the aspects of the fossil record that make the flood an impossibility.
Grayson, if I could, I'm going to jump in the last couple of minutes, and I'd like to utilize the last couple of minutes to address what you just said, Grayson. Also on the Mary Schweitzer argument, I'd like to reiterate that and get David's response to that out of curiosity. And so again, Grayson, let me know if I'm iterating it properly. So you said Mary found collagen fragments and not DNA. And the proteins discovered could apparently be preserved over many millions of years. And specifically, the state of the molecules would actually require the millions of years. Okay.
Yes.
David, I'd be curious
to elaborate on some of the specifics. Sure. The collagen that she found was highly fragmented and highly cross-linked. So the cross-linking explains why it was able to persist for millions of years. Cross-linking is a type of chemical bond that can preserve the structure of something like collagen. Now, what Mary Schweitzer did not find were any of the biomolecules that would quickly degrade. So any of the biomolecules that would degrade in a few thousand years are completely gone. So if those bones were only 6,000 years, we should still expect to find the biomolecules that would not have degraded yet within that time frame. But we don't. That's why what Mary Schweitzer shows, it cannot be only 6,000 years. It has to be older than that. There is a creationist, Dr. Fuzz Rana, who has a PhD in biochemistry, who has said the same thing. Like, when he looks at the actual biochemistry of what Mary Schweitzer found in those preserved soft tissues, he clearly explains that it debunks a young Earth and can only be explained by an old Earth model.
Okay, so, and before you respond, David, so basically you're saying the collagen was highly fragmented. It was also cross-linked, which is a type of chemical bond that can preserve these collagen structures in the first place. But she did not find any biomolecules, basically, that would degrade quickly in a young Earth creation time frame.
Yeah.
Okay.
Well,
David?
that would degrade beyond maybe I didn't phrase that correctly. Like, there are things that would be present if those bones were only 6,000 years that are not present in the bones.
Okay. Understand. I understand it. Grayson, appreciate it. David, if you'd like to respond, go ahead.
Oh, yeah, I for sure want to respond. Those of you in the audience that would like to pursue this issue need to know a couple of names that'll help you out. A creation scientist named Brian Thomas spent many years at a university in England studying the issue of soft tissue, and specifically the kind of soft tissue that Mary Schweitzer saw. Now, for those of you that may not be aware of this argument, let me give you a bit of a background using my whiteboard here. Schweitzer had a background in forensic science. And so she had actually worked before she had gotten interested in this Western U.S. fossil locality where there were dinosaur bones. Before she walked onto that site, she had had a partial career in studying forensic science. And so when she and her graduate students began to work with these bones, they used standard paleontological methods to encase the bones in canvas and plaster and so forth. Well, they underestimated the weight of all this. So when they removed the bones from this pit, they were actually dropped and broken. And so when she walked over to the bones, and I'll use a femur bone as an example. I don't know exactly which bone it broke, but when she walked over to it, she turned to her graduate students and said, you know, this is bizarre. This looks and smells like a crime scene. You know, I'm actually smelling what appears to be blood. Well, so they take these fossil materials, and like Grayson says, these are millions of years old, presumably. They take them back to the lab and they begin to look at them. Well, as she looks at them underneath the microscope, she sees what we have now come to call in creation science dinosaur soft tissue. She saw what appeared to be veins and arteries that when she pulled them out, they stretched as if this material was only a few days old instead of the flood geology argument of 4,000 years, much less millions of years. So Grayson is quite right that young Earth creationists have a partial problem with Dr. Schweitzer's work, but I'd rather have that problem of trying to figure out why some of these tissues, perhaps because of the presence of iron in them, were able to last 4,000 years. I'd much rather have that problem than going all the way back to 70 million years. I would suggest to you, Grayson, that you're overlooking the PhD work that Brian Thomas did on collagen in these fossils. Is that a valid critique, you think?
No, because Mary Schweitzer does not acknowledge that as a valid critique. She doesn't think that this is a problem for an old Earth model. So the very researcher who discovered this does not agree with your characterization of it. And she also did not find bone. She wasn't finding, like, she was finding like fossilized structures that looked like blood cells and looked like capillaries. They were fossilized, they were mineralized. It was only after she chemically treated the bones to dissolve away the mineral content that she was able to get anything that could be pliable, like you're describing. So no, this, and again, she does not consider this to be a problem for an old Earth to explain. Okay? So the very researchers who are the ones that are the most familiar with this work do not consider it to be a problem.
Okay, let me respond to that. When I was your age, I was able to donate blood. And sometimes when I donated the blood, my blood pressure would be 100 over 50. And they would say to me, and I was in my 20s, they would say, you know, McQueen, you can't donate blood today because if you get up, you're going to pass out. But when I was able to donate blood, I noticed that the nursing staff would very quickly take my whole blood and make sure that it was refrigerated. And that's so that the components of whole blood could be spun out for the different things that they would use it for, plasma and platelets and so forth. But my challenge to you, Grayson, is if a modern phlebotomist takes that much trouble with my whole blood, how in the world could soft tissue survive over millions of years, as in Dr. Schweitzer's science here?
Well, the blood did not survive. There's not like there's blood in these dinosaurs. There's fossilized structures left behind that are, again, mineralized structures that look in the same. They've taken on the shape. They are fossilized blood cells, but they are not blood cells. Okay, they are fossils. Okay, in the same way that a fossil skeleton is not the same thing as a skeleton. There's a difference in chemical composition and degradation state. So again, this is not like she's finding dinosaurs that look like they just died last week. That is a mischaracterization of her work. And again, this is a big reason why Mary Schweitzer's own work now includes a disclaimer up at the top that says, do not you misuse my work, creationists. She specifically tells creationists to stop misusing her work. She is sick of it. And so, this is just another one of those examples of mischaracterizing what she found.
Okay, let me jump in, gentlemen. So what we'll do, Grayson, you started the discussion. So if you both think it's fair, David, let's give you the last word for the discussion, and then we'll jump into... No, actually, I'm wrong. David, you started the discussion. No, actually, I'm wrong. And so why don't we wrap it up
I'll let
here?
David get the last word on this. It's
okay.
fine.
David, you have the last word, and then we're going to jump into our 5-minute summaries before we enter an intermission and then allow TRock to join. So great discussion so far. David, go ahead.
That's very kind. In a month or two, I will turn 71 years old. And so I am truly, factually, a grandfather, but I'm also a fairly ornery old man. And so there's a side of me that doesn't care what Mary Schweitzer says today, because what she says today is preserving her professorial life. She's probably at the age she got to put children through college, and she can't very well say, oh man, those creationists were right all those years ago, because why? She would lose her job. And so I realize that scientists like her probably do have to put a disclaimer at the top of the page, because why? If she even hinted to the fact that the creationist viewpoint of her work was true, she would lose her job.
Well, thank you for those final words, David. Grayson and David, excellent job making for a professional back and forth discussion. We managed to get about 50 minutes, and we had some really interesting back and forth on a number of important topics. So what we're going to do now is 5-minute summaries in order to wrap up our thoughts and points, and even address anything that we feel like we may not have had an opportunity to do so. To the audience, I've got all the questions saved and organized, and so I'm looking forward to the audience Q&A, which is after part 2. So after the summaries, we're going to have a 10-minute intermission, and then we're going to have TRock join for part 2 of this event. Grayson will be engaging TRock for part 2. So Grayson, appreciate the endurance and time you've given to us. Okay, David McQueen, 5-minute summary whenever you're ready.
Can I go first in the 5-minute outros because David just went?
Sure. Yeah, that's a good idea. So Grayson, we'll give you the first 5. David, you'll get the last 5.
Thank you.
Okay, just really quickly to address what he just said about Mary Schweitzer. I'm pretty sure Mary Schweitzer has tenure. She's not going to get fired for any of this stuff. I mean, you have to do something very, very extreme to get fired when you have tenure. And also, I'll just point out that her entire career is her going up against the consensus. She has been challenging the consensus from the very get-go. And guess what? She wasn't fired. She still kept her job. You can totally challenge the consensus and keep your job, especially when you have tenure. So I reject the notion that she's adding this just for some kind of, pressure, external pressure from her employer to keep her job. Very conspiratorial line of thinking. I don't understand why you can't just accept that Mary Schweitzer doesn't think that her work is a good argument for young Earth creationism. That seems like Occam's razor, the most simple explanation is that Mary Schweitzer just doesn't agree with you. It's not like there's this whole hidden agenda and she has to suppress the truth because of her employer threatening her financially and making her put in a disclaimer. And it's nothing of the sort. It's literally just she doesn't agree with you. And just again, we covered a ton of ground tonight, but I never heard a single explanation that could adequately explain how the flood segregates fossil species into layers. We observe this with plankton. We observe this with trilobites. I mean, he said that, the trilobites are all the same kind. They just look different. Then why are they segregated into layers? It doesn't make sense. You said, well, if all my kids look different, but they're still the same species. Well, yeah, but if your kids were segregated into different kinds of layers, like in rock, there would need to be an explanation for how your daughter ended up in a different layer than your son. Like, you would need a physical explanation for why they're not all in the same layer, because they all have the same, they're both all humans. They should be in the same layer. So if they're not in the same layer, you need a physical explanation. That's all I've been asking for all night, is what is the physical explanation for how a flood can possibly produce the fossil record that we see. And just to address your point about the trilobites at the bottom with the clams, and then you have it goes up in order. Well, guess what? There are clams at the very top. There are clams in the Cenozoic layer. There are plankton in the Cenozoic. There are plankton in the Mesozoic. There are plankton in the Cambrian. So again, you got to explain how that could possibly be possible at all with a flood. That's what I wanted to hear from tonight's debate, and so far I have not heard it.
Grayson, thank you for the 5-minute summary and closing arguments. Actually, I'm wrong.